Having given you some background about supernovae and gamma ray bursts, I'd like to talk about now about some work that we have been doing at Tata Institute um, with other colleagues in other places in the world, primarily in the United States and Chile. And I would like to discuss with you in the remaining few minutes a special object which shows um, all the characteristics of having a central engine, uh, uh, which is implied in the core of a gamma ray burst um, in terms of the relativistic outflow that is seen in gamma ray bursts normally. The relativistic outflow is seen in this particular supernova, namely supernova 2009 BB, which exploded last year in the month of March. And it was targeted by the Very Large Array in the United States, as well as the GMRT, which is near Pune in Maharashtra. And we found that the expansion of the plasma that is responsible for the radio emission was at a special relativistic speed, namely a good fraction of the velocity of light. But even though we had extensively searched for gamma ray emission from this object, and many satellites were looking at its direction sometime or other in a given time window where we expected that if there was a gamma ray burst, it could be detected. But we found no evidence for any associated gamma ray burst. So it is like the story from Alice in Wonderland, where you see the cat, you see first a cat, but the cat slowly vanishes, and what remains is only its grin, and the cat becomes invisible. So this is like a grin without a cat. Next slide. So our collaborators in this work that we did on Supernova 2009 BB is Alicia Soderberg from Harvard and Shayan Chakraborty from TIFR. Shayan is a doctoral student in TIFR. And Poonam Chandra, who was also a doctoral student at TIFR. And the paper that we published in Nature magazine was titled A Relativistic Type 1 BC Supernova Without a Detected Gamma Ray Burst. And I have here an excerpt from Alice in Wonderland to drive home that this was a central engine-driven supernova, but without the associated GRD. So Alice was complaining, "I wish you wouldn't keep appearing and vanishing as suddenly, so suddenly. You make one quite giddy." "All right," said the cat, and this time it vanished quite slowly, beginning with the tail and ending with a grin, which remained some time after the rest of it had gone. "Well, I have often seen a cat without a grin," thought Alice, "but a grin without a cat, it's the most curious thing I ever saw in my life." So when Supernova 2009 BB was discovered, we were quite puzzled, and we also were thought that it is indeed a rather curious thing, which shows all the characteristics of this central engine associated with the GRD, but it didn't show a GRD at all. So what could it be like? Next slide. shows an image of the supernova 2009 BB, which is on the left, and it's the bright spot on the lower right corner. Um, um, the image is made by the GMRT, the Giant Meter Wave Radio Telescope near Pune, at a wavelength of 50 centimeters. And the supernova actually appears in a region of a so-called H2 region, which is also an enhanced a region of enhanced radio emission. So there is a bit of a contamination which we have to somehow separate out by studying the supernova, by studying the region at different wavelengths. If you have higher resolution of an image, which can be obtained at high frequencies, you could then subtract off the contribution that you expect at low frequencies from the supernova. Supernova's emission, which is contaminated by the local local region not quite associated with the supernova. And the pictures on the right show the images of GMRT and the VLA, with which this extensive follow-up of this important supernova was undertaken. Next slide. Having given you some background